Okay, next problem is a lot easier. It just wants to say what are the numbers that are not in the domain, so the numbers that don't work. Obviously, the things we look out for are zeros in the bottoms of fractions and negatives underneath square roots. We don't have any square roots, so we're looking at the bottom of this fraction. We can factor it into x minus 3, x minus 2, and we can find out that the places we can't have are 3 and 2. So 3 and 2 are places where this function is 0 in the bottom, and therefore undefined. All right, I'm going to ask you a really challenging one now for the domain of this. Now, for the domain of this, I know that I can't have negatives underneath square roots. So basically, the top, this 4 minus x squared has to be greater than or equal to 0. I can have it be 0, because 0 is fine in the top. And in the bottom, square root of 1 minus x squared, we know that that has to be positive as well. And that can't be 0, because if it's 0, it's undefined in the bottom. So I have to satisfy both of these inequalities. So to do that, I'm going to solve both of them. I'm going to subtract 4. I get negative x squared is greater than or equal to negative 4. I'm going to divide by negative, which gives me x squared is less than or equal to 4. And then I'll square root both sides, which gives me x is less than or equal to 2, or x is greater than or equal to negative 2. So on a number line, let me graph that real quick. That's all the numbers that are greater than or equal to negative 2 here. Here's 0 and here's 2. All the way up to the numbers that are less than or equal to 2. So I'm looking at this interval right here from solving the first one. Those are all the numbers that I can stick in and still have positive values in the numerator. Now, I still have to do that for the bottom as well. So I'm going to do it for the bottom now. I'm going to subtract 1 to get negative x squared is less than negative 1. I'm going to divide by a negative, which gives me x squared is greater than positive 1. And then I'm going to square root both sides, so that gives me x is greater than 1 as well as x is less than negative 1. So I actually just made a mistake when I did this. I put this inequality wrong the first time, so let me do this again. This would be negative x squared if I subtract 1 from both sides is greater than negative 1. Now I get x squared is less than 1 if I multiply through by a negative. Square root both sides, and that gives me x is less than 1 or x is greater than negative 1. So now let me draw that in a different color, red. Here's 1 and negative 1. I can't have those values, negative 1 and 1, but I can have all the points in between. Right? So x is less than 1 and greater than negative 1, not including those points. Those are open circles. So those are all my answers. That's my domain. I can't have the blue points here because the blue points, they satisfy the top, that's fine, but in the bottom they're negative. Like if you stick in negative 1.5 into the bottom here, we know that doesn't work. It's not in the domain. We know those points aren't greater than 0, so we just solve. So if you stick in 1.5 right here, you'll get a negative number, which is not okay for this problem. So I have to take the more restricted area, which is negative 1 to 1. Okay, I know it's a really tough problem, but if we practice that a few times, we have to basically have what's underneath the top radical be positive or equal to 0. And we have to have what's in the bottom be strictly positive. Turns out that what's in the bottom is more restricted. It's just these points here. So we have to give that as my domain. Let's try another one then. The domain of this, basically 11x over x squared minus 4 has to be greater than or equal to 0. Because we can't have negatives underneath the square roots. The other thing we can't have is x squared minus 4 cannot be equal to 0 because that's undefined. So let's find out where x squared minus 4 is equal to 0 first. That's x squared equals 4. Square root both sides, and we have issue at x equals plus or minus 2. So those are 2 points we've got to look at that are undefined. Okay. Now also we want this thing to be positive. So I'm going to factor the bottom to x minus 2, x plus 2. X minus 2, x plus 2. And I'm going to make a sign chart like we've done in the past and figure out where this thing is greater than or equal to 0. So the key points on there are 0 because that's one of the zeros from the top, as well as 2 and negative 2. So I'm going to put on there negative 2, 0, and 2. And I'm going to test to find out, let me write what these are as well. Negative 2 is, this is an undefined spot, this is a 0, and this is an undefined spot. I'm going to test the point less than negative 2 like negative 3. That gives me a negative in the top, a negative here, and a negative there, which turns into a negative. I'm going to pick a number between negative 2 and 0 like negative 1. Negative 1 gives me a negative in the top, a negative here, but a positive there, so that'd be positive. Now I'm going to pick a number like 1. 1 gives me a positive in the top, a negative here and a positive there, so that'd be negative. And 3 gives me a positive in the top, a positive here and a positive there, so that's positive. So I want this thing to be greater than or equal to 0, which means I'm looking for the positive spots here. So that'd be from -2 all the way up to 0. I can include 0 because that point is a 0, which is fine. And all the way from 2 to positive infinity as well, I can't include the point 2. All right, so by solving this, by making sure that this was positive, we found the domain. And as an interval, that would be -2 all the way up to 0. I could include -2, as well as from 2 all the way up to positive infinity, which you might have to enter in as INF. And I can't include 2. So that's my answer right there in interval notation for the domain of this function. All right, let's try another one. The domain of this function is all the places where x is greater than or equal to 0, because obviously you have to take what's underneath this radical and make sure that it's positive. So in interval notation it wants it in, so that'd be from 0 all the way up to positive infinity. You can include 0, so I'd enter that in. And the range then, if you think about it, x has to get bigger. So the smallest that y can be is 18, and it can be 18 if x is 0, but it goes all the way up to positive infinity because the bigger x gets, the bigger y gets. So this would be my range from 18 to positive infinity. Okay, the next problem has the cube root function. Now, I can take the cube root of any number I want, so it doesn't matter if this thing's positive or negative. It doesn't matter. The cube root of a negative number is just a negative number. So this is fine. I can do negative infinity all the way up to infinity here. There are no restrictions. Only for even roots do we have an issue with negatives underneath the radicals. So the domain for this, I can stick in whatever number I want. Okay, this is a piecewise function. You can actually graph these however you want, but it's this line 4x minus 8 for whenever x is less than or equal to -2. So basically I'm going to draw this line. It's got a, I'll do this quickly, just a rough sketch. And this thing's -8, and it's got a slope of 4, so it goes up really quickly. But I'm only going to draw it from -2 on back. So I'm only going to draw it from like this point on back, because it's only this line for when x is less than or equal to 2. And then it's this other line which goes up to 6, starts at 6, and has a slope of -1/2, so it goes down kind of slow. And it's an open circle at 2 and then goes this way, right? Because at 2, this thing's defined on this line down here, so that's a closed circle down here. And then the function jumps up here and goes like that. So it's asking for the domain, which is actually all real numbers, because I can stick in whatever I want. If I, all these points, it's just if I stick in a negative number, it's going to be on this line. If I stick in a number bigger than 2, I'm sorry, I used -2 here. It's actually supposed to be 2, so this thing's supposed to go up to 2 right here, and then this one would start at 2. So it'd be an open circle there and go. That's better. But either way, I can stick in whatever x value I want. And then the range is all real numbers, but I can't go bigger than this point because you can see this function goes down. So at this point 2, this function is at 5, looks like. Plug in 2 here, you get a 1, so 6 minus 1 is 5. So that's 5 right there. So basically, I know that my range is all the y values that are less than or equal to 5, which in interval notation, that would be negative infinity all the way up to 5, and I can include 5 because that's what I get when I stick in 2. Actually, I'm sorry, when I stick in 2, the function is defined down here, so I do need a parenthesis there. I'm not including 5, so negative infinity all the way up to 5, use INF for infinity. Next problem, try to do this without a calculator, but just to practice with function notation again, when you plug in -3, you get 2 -3 squared, which is 9, minus -3, which is really 18 plus 3, which is 21 in the top. And in the bottom, you get -3 squared is 9 plus 4, which would give me 13 in the bottom. So 21 over 13. So what you get for the first one. Now plug in -4. -4 squared is 16, so it would be 2 times 16 plus, or minus -4, which is really plus 4, which gives me 32 plus 4, which is 36. And then in the bottom, you have negative 4 squared is 16, plus 4, which is 20. So 36 over 20, which simplifies to 18 over 10. Divide top and bottom by 2, which simplifies to 9 over 5. You divide top and bottom by 2 again. Okay, if you plug in 0, you get a 0 on the top, and you get 4 in the bottom, which is just 0. And then the domain of this function is all real numbers except for where the bottom is equal to 0. So let's find out where the bottom is equal to 0. And it's never equal to 0. Right? If you subtract 4x squared is equal to negative 4, square root it, you can't take the square root of the negative. So this is a parabola right here that's been shifted up 4 units. So we know that's never 0. So the bottom is never 0, which means the domain of this is anything I want. Okay, you guys can try this one. It should be pretty straightforward. The one thing you can't have is in the bottom for the domain. You can't have x equals negative 4 because that gives you an undefined in the bottom. So it'd be negative infinity all the way up to negative 4, not including negative 4, as well as from negative 4 to positive infinity. That's the way we're going to have to write that, unfortunately, right there. Next problem, the domain of this goes from 3 to 21, you can see. So we go from 3 to 21, including both those points. And the range goes from 4 all the way up to 20 for the y values. So 4 to 20. And it looks like I can include both of those points as well. Now, I think it says inequalities it wants. So for an inequality, for the first one, I'm going to have to do 3 is less than or equal to x is less than or equal to 21. And then for the bottom one, I'm going to have to do 4 is less than or equal to y is less than or equal to 20. If it wants inequalities. All right, I hope this helps.